Friends, today we are going to learn about semiconductor electronics. In chapter number 3, current electricity, we have studied about the relation between voltage and current. Means when the voltage is increases, the current is increases. Now in semiconductor, if we somehow control the motion of the charge carriers, then we can build up the relation voltage and current somehow different. In chapter number 3, the relation between voltage and current like this, voltage and current. Suppose voltage and current. Now if we take some values of voltage, V in volt and I in ampere. Suppose V is equal to, if we take 1 volt, then current I increases 0.1 ampere, just for example. Now suppose V is equal to 2 volt, then I is equal to 0.2 ampere. Now again we take V is equal to 3 volt, current I is equal to 0.3 ampere. Now plot the values of voltage and current in graph. Voltage V is equal to 1 volt, 2 volt and 3 volt. Current 0.1 ampere, 0.2 ampere, 0.3 ampere. When values of voltage V is equal to 1 volt, at that time current I is equal to 0.1 ampere. Means 1 and 0.1, 1 and 0.1. V is equal to 2 volt, at that time current values of current I is equal to 0.2 ampere, 2 volt and 0.2. Now V is equal to 3 volt and I is equal to 0.3 ampere, 3 volt and 0.3 ampere. Now starting from the 0, the graph is straight line. It means it suggests that when the voltage is increases, value of current is increases. Now in chapter number 14, semiconductor electronics, if we somehow controls the motion of the charge carriers, means when voltage, values of voltage V is equal to voltage and current, values of voltage V is equal to 1 volt, at that time current I is equal to 0 ampere. Now V is equal to 2 volt, again current I is equal to 0 ampere. When V is equal to 3 volt, current I is equal to 0.1 ampere. Means up to 2 volt current remains 0. After that when we increase the voltage V is equal to 3 volt, at that time current set up in the device. Means if we plot the graph for semiconductors, for semiconductor and for current electricity. Now if we plot the graph for semiconductors, then voltage and current. Voltage V is equal to 1 volt, V is equal to 2 volt and V is equal to 3 volt. Current I is equal to 0.1 ampere, 0.2 ampere, 0.3 ampere. When V is equal to 1 volt, V is equal to 1, at that time current 0. V is equal to, current I is equal to 0, again 0. And V is equal to 3, at that time current set up in the device. Means graph look like in this way. Means the difference between, we can see on the board for current electricity and for semiconductor electronics. The difference between two graphs is In semiconductor electronics, if we somehow control the motion of the charge carriers, here we control the motion of the charge carriers, and for good conductors Ohm's law obeys. Now for semiconductor electronics, means in semiconductor electronics, in chemistry we have learned about the periodic table. There are periodic tables. In periodic tables divided into 3 categories: for number of charge carriers free in them, conductors, semiconductors and insulators. In conductors we can see the more number of free electrons in the conductors. In insulators there is very less number of free electrons in the insulator, that is insulator. And the between is compared to conductor, less number of free charges, and as compared to insulator, more number of free charges, that is semiconductors. So we have seen in periodic table first 3 group of the periodic table, that is alkali and aluminum, are good conductors because there are number of free electrons in them. And last groups of the periodic tables, that is bad conductors, because there is very less number of free electrons as compared to the conductors. And between them, conductors and insulators, that is semiconductors. Fourth group of the periodic table, that is silicon and germanium. Silicon and germanium are semiconductors. Why that is semiconductors? Because there are more number of free electrons as compared to the insulators, and there are less number of the free electrons as compared to the conductors. That's why we can say silicon and germaniums are semiconductors. Silicon and germanium, fourth group of the periodic table. That's why because of the fourth group of the periodic table, silicon and germanium at absolute 0 Kelvin temperature. Silicon and germanium at absolute 0 Kelvin temperature, it behaves as a insulators. Mind well, silicon and germanium at absolute 0 Kelvin temperature, there are insulators because of there are very less number of free electrons in the silicon and germanium at absolute 0 Kelvin temperature. Now if we want to increase the conductivity of the semiconductor like silicon and germanium, if we want to increase the conductivity of the semiconductors like here silicon and germanium, then we can increase the temperature. We can increase the temperature in the silicon and germanium, and more number of the free electrons and conductivity increases. Now question arises here, why semiconductors are required? Because semiconductors are less in dimension, more reliable, cost are very low as compared to the other devices. Now semiconductor electronics, in semiconductor electronics, first the diamond structure of the silicon. First we have seen diamond structure of the silicon. We know that the atomic number of the silicon, that is 14. Atomic number of the silicon, that is 14. And electronic configuration, in chemistry you have learned about the electronic configuration of the silicon. Electronic configuration of the silicon is 1s2, 2s2, 2p6, 3s2 and 3p2. So diamond structure of a silicon. So first atomic number of the silicon. of silicon. Atomic number of the silicon is 14. Electronic configuration. Electronic configuration of silicon. 1s2, 2s2, 2p6, 3s2 and 3p2. 2 plus 2 4 plus 6 10 plus 2 12 plus 2 14. Atomic number of the silicon is 14. 14 electrons can sit in the cells. Now here S, P, D and F are orbits. And K, L, M, N are cells. In semiconductor electronics, S, P, D and F are orbits, K, L, M and N are cells. We know that we have learned in the chemistry, in S orbits the maximum number of electrons can sit in the S orbits. There are 2. Maximum number of electron can sit in the p orbits, that are 6, and maximum number of d in electron can sit in the d orbit, that is 10, and in f the maximum number of the electron can sit 14. Now here we require only s and p orbits, then we can talk about only s and p orbits. Now in first 1s2, 2s2, 2p6 are completely occupied, means completely filled. Now 3s2, 3p2, in 3s2, 3p2 orbits K and L cells are incomplete, because in 3s2 in s orbits number of electron can sit, maximum number of the electron can sit in the s orbits, there are 2. In p the maximum number of the electron can sit in the p orbit, there are 6, but here 2 electrons, means p orbit can attract another 4 electrons from neighboring atoms. P orbits can attract another 4 electrons from neighboring atoms and it becomes stable. Now in 3s2, 3p2 orbits are incomplete. Now in p orbit number of electrons 2 and maximum number of the electrons in p orbit 6, means there are 4 electrons can attract, means 4 electrons, 4 means tetra. That's why we can say silicon is a tetravalent. Understood? Why silicon is a tetravalent? Because in outer orbit there are 4 electrons can attract, another 4 electron can attract and it becomes stable. That's why we say silicon is a tetravalent. Now silicon, diamond structure of a silicon. Silicon atomic number 14, tetravalent, in outer orbit 4 valence electrons, 4 valence electron, 1, 2, 3 and 4. Same way 1, 2, 3 and 4. Again 1, 2, 3 and 4. Again 1, 2, 3 and 4. Silicon 1, 2, 3 and 4. Each silicon atom having 4 valence electrons. We can see on the board 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. We know that silicon and germanium are semiconductors. Semiconductors at absolute 0 Kelvin temperature, semiconductors behaves as a insulators. Now at absolute 0 Kelvin temperature, silicon behaves as a insulators. Now at that time, by sharing silicon having 4 number of electrons vacant, by sharing one electron with another neighboring atom, and it forms a covalent bond. By sharing one electron with neighboring atoms, it forms a covalent bond. In same way here, by sharing one electron, it forms a covalent bond. Same way here, by sharing one electron of each silicon atom, it forms a covalent bond. Now question arises, why silicon is a diamond structure? Silicon atom having diamond structure. Now we can see in 3D. Silicon atom, silicon, 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 silicon. By sharing one electron, it forms a covalent bond. Now in 3D we can see in this way the diamond structure. Diamond structure of silicon atom. Silicon is a diamond structure. Now next topic is concept of holes. Now hello students, please take this screenshot of this. Silicon is a diamond structure. Now next we will see the concept of the hole. Next topic in semiconductor electronics, that is concept of hole. In previous topic we have seen the silicon having 4 valence electron. Each silicon atom having 4 valence electron. By sharing one electron with neighboring atoms, it forms a covalent bond. At absolute 0 Kelvin temperature, at absolute 0 Kelvin temperature, it behaves as an insulator because no number of free electrons at absolute 0 Kelvin temperature. All the electrons are in bound condition in covalent bond. That's why the conductivity is very less. We can say 0, approximately 0. Conductivity at 0 Kelvin temperature is approximately 0. That's why we can say at absolute 0 Kelvin temperature, silicon and germanium are behaves as a insulator. Now, concept of holes. Now, what happens when silicon at room temperature? Room temperature means, for example, 25 degrees Celsius. At room temperature, what happens when we increase the temperature from the absolute 0 Kelvin temperature? At that time, thermal oscillations. Because of the thermal oscillation, the diamond structure of the silicon starts oscillating, means vibrating. Oscillating means vibrating. Because of vibration, why vibration starting in the silicon diamond structure? Because when the temperature is increases, the covalent bond is covalent bond breaks and electrons becomes free from the covalent bond. When temperature is increasing, thermal oscillation means vibration starting in the diamond structure. At that time, some of the electrons are becomes free. For example, suppose these electrons becomes free at the time of oscillation due to vibration. When we increase the temperature, because of the vibration, these electrons becomes free from the covalent bond and it take a part in conduction. Now here deficiency of the electron. Because when we increase the temperature, because of the thermal oscillation, electron becomes free. Now that electron take a part in electrical conduction. Now at that place, from that electron becomes free, that place is deficiency of the electron. Now here blank space, we can say blank space. Now we all know that electron having negative charge. When negative charge becomes free, we assume that here blank space having positive charge. Just imagine that at that place positive charge. Now deficiency of the electrons. That deficiency of the electrons is called hole. Again I repeat, when we start thermal oscillation, because of the vibration, temperature increases, covalent bond breaks. Because of the breaking in the covalent bond, electrons becomes free. That electron take a part in electrical conduction, and from that electron becomes free. At that place, deficiency of the electron. That deficiency of the electron is called hole. Now if we imagine hole behaves as a positive charge, because electron having negative charge and behind that it leaves the positive charge. Now again we continue increase the temperature of the silicon structure and thermal oscillation again starting speedily, and again another electrons becomes free from here. At that place, deficiency of the electron, that is hole. And that hole can trapped inside the hole here. Now it fill the space. Understood? Again we increase the temperature, covalent bond breaks from here, and that electrons can jump inside this hole, and here again covalent bond forms. and that process is continue till the all the electrons becomes free, means maximum number of electrons becomes free from the covalent bond, and that electron can take apart all the electrons in electrical conduction, and in this way the electrical conduction can take place in the semiconductor devices or semiconductors, that is silicon and germanium. Silicon and germanium, the minimum energy required for silicon and germanium to escape from the covalent bond. Note down the minimum energy required for silicon and germanium to escape the covalent bond. For silicon, that energy is 1.1 electron volt, 1.1 eV, and same for germanium, 0.72 electron volt, 0.72 eV. Most important question for examination point of view in Gujarat board, first 50 MCQ, mostly frequently asked question, silicon having energy to escape the covalent bond, germanium having energy to escape the covalent bond, minimum energy required for to escape the silicon and germanium atoms are 1.1 electron volt for silicon and 0.72 electron volt for germanium. Understood? Semiconductor electronics. In semiconductor electronics, again, if we somehow controls the motion of the charge carriers, then we can build up the number of the relations between voltage and current, between voltage difference and the current. Now, if we apply the potential difference, if we apply the potential difference across this crystal, then what happens? That we have seen later. Okay, today we have seen about the semiconductor electrons, that is silicon is the diamond structure concept of hole, and tomorrow we will see about the electrical conduction, means biasing of the crystal when we apply the electric supply to the crystal, then what happens.